Hello, everyone. Welcome to episode 7. Before we begin the formal presentations, I'd like to take you through some of the features of this webinar software. If you have any problems at all, please use the question box in the control panel. This will be on the side of your screen. We'll try to help with anything that we can do on our end with any difficulties. We'd also like you to encourage the asking of questions in context as you think of them. So you can use that same question box to go ahead and ask your questions. Please feel free to use this throughout the webinar, and we'll try to get to as many as we can during the webinar itself, and keep to time and perhaps save a few towards the end. Lastly, you'll receive an email tomorrow with a link to the recording of the webinar, and you'll notice we have 3 handouts, and so please look at the handout section of the control panel to be able to look at the 3 handouts from today, including the slides that we'll be going to. And finally, there's a short survey at the end, including an offer from the folks here at XLSCOUT. Please take just a few minutes, it shouldn't take more than 30 seconds actually, to fill in the questionnaire at the end. Your feedback really helps us as we continue to develop the series. Okay, so once again, hello and welcome to episode 7 of ML4Patents.com webinar series, this time featuring XLSCOUT and their new explainable AI product. My name is Tony Trippi. I'm the founder of MachineLearningForPatents.com and managing director of Patent Informatics. And I'm joined today by a couple of the folks here from XLSCOUT. I'll start with Jatin Talwar. He helped found 2 global companies, TT Consultants and XLSCOUT. He was a patent agent in India, continues to be a patent agent in India, and he's an experienced patent attorney. He is also a Gurukul Fellow at the University of Oxford, DPIR St. Cross College. He represents future clients at the Indian Patent Office and subsequent litigations, consulting on portfolio management, design around compulsory license avoidance, and prior art searches. He is continuously working towards inventing a series of new techniques in collaboration, automation, and enhancing viewing of patents by use of AI, machine learning, and blockchain. He has addressed seminars and conferences on several important IP issues, including best practices of developing and protecting IP in US, Japan, Taiwan, China, and India. We are also joined by Dr. Nirmal Basi, who has a PhD in biochemistry. He's a registered patent agent with the USPTO and has published numerous peer-reviewed journal articles while he was a research scientist at the National Institute of Health in Bethesda, Maryland. He has been a patent agent / consultant working closely with clients to develop an asset of value based on intellectual property for the last 4 years. With over 12 years of experience as a patent examiner at the USPTO and having reviewed hundreds of patent applications in the biotech era, he's guiding search teams at various steps through regular training sessions, helping them during the search and assisting them in finding better results. And so with that, I will turn it over to you, gentlemen, to begin the presentation.
Thanks, Tony. I'll take that. Thanks, everybody, for joining in. I see a very good set of attendees, and I'm very impressed with how Tony set this up. So today we'll be presenting XLSCOUT that was initially germinated as a result of my project at Oxford and is now coming up at fruition after about 16 months of research and about almost 8 years of background work that we've done on the base technology. It's a multi-country, multi-organization research effort, and we'll present to you an explainable AI-based landscape system. Now, one of the most important aspects of any AI implementation in a commercial setup is the explainability of this AI. It's one of the most important factors that is impeding adoption of AI systems in patent departments. There's a lot of AI systems, but for a serious IP department to stand behind any AI, there is got to be explainability and lack of bias behind the system. On your screen, you see a study that was done by McKinsey, and in this survey and research which was done, as you can see at number 3 with this yellow mark, you can see explainability is one of the most important concerns that enterprises feel when it comes to standing behind any black box kind of an approach. At the end of this presentation, we'll be presenting, we will be showing you a real-time landscape. We'll show you how we're using explainable AI, and we'll show you how this landscape has been tested and is found to be between 95 and 98% accurate and consistent. And I like to flag this fact that it's more than most of the humans have been able to achieve. Next slide. Now, the other part of it is that what we bring to you is not just a black box approach, but a glass box approach, and and something that is explainable and validated and accurate to the extent of about 95%. Next slide. So when analyzing patents or grouping of patents is a key function. It's here where we are implementing explainability. You see this top line where companies that are looking to group and create technology landscapes or try and look at competitors for their landscaping systems. What they're looking to do is have at a top level technology clusters or technology clustering which could be automated. Because what you're looking for is leveraging these clusters and then doing analysis of either your portfolio or business segments or competitors, etc. So continuing to do technology clustering and doing that automatedly is one of the most important factors when it comes to any technology or a patent landscape, or if you're tracking any competition in real time. Next slide. So what you end up doing and what XLSCOUT brings in is explainability, which is like this Venn diagram where you combine accuracy, automation, and confidence. And what you get in the center of the Venn diagram is explainable AI. And XLSCOUT provides just that, as we will present you in real time as we move forward today. So with present you in real time as we move forward today, added to your shopping list. So there's Siri at the background, which is added this to the shopping list. Okay, so with XLSCOUT, you get clean global data that you can use. The data is comprehensive, as you can see. It's a database of all the world's patents. It's clean, it's comprehensive. You can leverage this data for a user-defined taxonomy. That's a very important aspect. The taxonomy is not something which is automatically assigned to the system or something. You define it. So what you see is what you get. And then at the heart of what we are working on is a very important aspect where we've created this 3 billion concept corpus. So what we did was we collected all the all the search strings that examiners might have put in, all the Wikipedia information, all the patent information, and created a corpus which is world's largest concept corpus, and it's a 3 billion concept corpus. Now it's also continuously learning. It also learns from you. It also learns from the global data set. So that's the heart of this machine, which then becomes explainable and the categorization happens. So it continuously learns and it gets more intelligent and incisive as one gets. So what you get at the end of it is, just go back a little bit. What you get at the end of it is reporting and calculation of matrices. You get data set of problems that your competitors are working on. You get a technology landscape, a company landscape, and everything is incisive along with alerts and reports, right? Next slide. So when you subscribe to XLSCOUT, it includes company landscape, technology landscape, manual taxonomy, which is user-assisted taxonomy, categorization, alerts, and regular updates. Next slide. So this is what gets listed. Now we'll come to the meat and potatoes of of this and work towards how this has been adapted, and we'll actually head into then like a real-time demo of how it works, and we'll show you how the adaptation works. Now, in as far as adaptation of the product is concerned, we've you can access it on XLSCOUT.ai. It's a partial list of companies and law firms which have adapted onto XLSCOUT is mentioned on the site. You can see these are real-time adaptations of companies that have kind of taken access to XLSCOUT. They're using and leveraging explainable AI for their day-to-day operations and work. And it's a very impressive list of companies which have been adding, and the company's been adding more and more users as things proceed. So what we will be showing today is a study on two aspects. The first one is sustainable development goals. What we've done is done a real-time study on Sustainable Development Goal 3, which has been created by the UN, and we've kind of categorized that. But what we will show you is how explainable AI can be used for automatically, real-time, explainably categorized sustainable development goals. And secondly, it'll bring a smile to Tony's face. What we've done is we've also created, Tony's been running this very interesting data set where there are some patents which are positives, some patents which are negatives, and they relate to qubit. So we'll go a step further, Tony, and bring some smiles to your face as well, and as far as the explainable AI application on qubit data set is concerned. So what you'll see next is a screen, and I'll have my colleague go through and go over the Sustainable Development Goal data set, and we'll take it from there. So Stuti is a customer support manager with XLSCOUT. She's also been responsible for developing XLSCOUT and doing extensive research on XLSCOUT, including machine learning applied by the corpus on the world's patent data set. And as we move forward, we'll keep shuttling between me and Stuti in as far as the demonstration is concerned. So Stuti, you can go on.
Thank you, Jitin. So we conducted a case study on Sustainable Development Goal 3. So SDGs are basically Sustainable Development Goals, which have been defined by the UN for addressing all the global challenges that are being faced today. There are in total 17 goals, and under each goal, some targets have been defined to indicate whether the goal has been achieved or not. For this case study, we have taken SDG 3, which focuses on achieving good health and well-being for all. And these are the targets based on which we have analyzed data on SDG 3. Now I'll walk you through the platform and show how XLSCOUT has been used for analyzing patents related to Sustainable Development Goal 3. So we started with a data set of over 13 million patents, all related to SDG. And as you can see, the data set is quite large to be analyzed manually. So that's where XLSCOUT's explainable AI-based system helps in the analysis. So for classification, we first have to create a taxonomy, for which we go to this taxonomy builder option, which helps you create a custom taxonomy. In this case, for creating a taxonomy, we linked all the targets that have been defined under SDG 3 to main level categories, and then further those categories have been divided into some subcategories. Now, 3 important points which I would like to highlight with respect to taxonomy creation is, first, that user can enter his or her own keywords as per the understanding of the domain, and also add some synonyms or technical variations to that. Second, as it's being pointed out, user can take help from the concepts which system has suggested by extracting these concepts from the mother population that we got. And third is to cover as many possible variations of these keywords by using the XLSCOUT corpus, which is a collection of over 3 billion words. So as you can see, if we want to look at all the different keywords related to maternal mortality, XLSCOUT is suggesting some like maternal death. Then we have neonatal death. So some of the keywords we've already included in the analysis. So you see that we let user define the taxonomy, and based on the input that user has given, XLSCOUT explainable AI system does auto categorization, and therefore it makes it highly explainable and transparent. So we can select the taxonomy categorization fields and then submit for the classification part. Yeah, so as you can see, we have all the results classified under the categories that we created. Now the analysis does not stop here. We further go to the analytics dashboard to extract some meaningful insights from the graphical visualizations. So on this technology intelligence dashboard, we have a wide range of charts that through which we can analyze this data. One of which is technology breakdown. So this, yes.
May I ask a quick question before you move on to this section?
Sure.
Just one thing that I wanted to get some clarification on. Now, the taxonomy that you've got in this particular case is pretty extensive, and based on what you were saying, I'm guessing that you developed this yourself. So working with the particular report that you were looking at, you came up with what the the classes and the subclasses, and you basically assembled the taxonomy as the user. The system provides a great deal of assistance in helping you populate it and therefore do the subsequent classification of it. But as the user, it was up to you to decide how many categories you wanted, how deep you wanted the hierarchy to go, and things like that. Correct?
Right. Yes.
And I think here in this next section, you're going to talk about some of the insights that you could then pump back into the taxonomy if you saw something there that you thought might be of interest but hadn't been covered yet, and then you could improve and create another iteration of the system. Is my assumption correct?
Yes. So based on the understanding of the domain, I created these categories, and definitely system helped me in that by suggesting some relevant keywords and then also some of the technology concepts. And then further, when we move onto the dashboard, we see how the patterns are falling under those categories. Okay. I hope I was able to answer your question.
Yes. Yeah. You know, because there's a key difference. And I think a lot of the people that are going to be interested in this system are going to be interested in developing their own taxonomies. There's something to be said for automatic taxonomy generation, but in that particular case, you're leaving a great deal up to the machine and not really leveraging the amount of subject matter expertise that's probably available from the client. So in this capacity, there's a little bit of time that takes place that goes into building the taxonomy, but most customers are going to have a great deal of knowledge about the way they personally think about their field. So if I'm in consumer products, I know what form that they take. I know what materials go into them. I know what processes are used to create them in the first place. And so I can begin to build a taxonomy that lines everything up by, well, you know, these, if I want to know about the forms, here are the forms. If I want to know about the materials, here are the raw materials. I want to know about the processes. And that way, it's easily adaptable and usable and applicable then to, say, their R&D clients, because they're all talking the same language. Instead of trying to interpret what the system thinks they might want to know, they're being very proactive about generating exactly how they want it to look from the start.
Yes.
Very good. Thank you.
You captured the right thing as well. There's also an option of automated concepts though. So we've retained that part, but when it comes to the manual taxonomy, the real user who's kind of working around, who's got to bet their credibility on the report which is generated or what is given an output, that real user would want their own taxonomies to be generated. And what we do as a part of the offer that we have for the viewers and the attendees of this webinar is that we do a proof of concept for corporate attendees to be able to show how this works and create proof of concepts on training people, enabling them, creating use cases, and create value for them. And you've captured it. You've captured the problem completely correctly.
I also wanted to add, I think the automated taxonomy could also be a help in certain instances, because when you're trying to make a taxonomy, there may be something the machine's going to suggest that could help you personalizing your taxonomy as well. So I think those concepts could be good as well. So a combination. I think if the person gets to use the program a little bit better, you can go backwards and forwards and kind of build that personalized taxonomy. That's going to be a great value.
Yeah, it's always super critical to let the data speak to you, because of course all of us go in with certain biases.
Right.
And if the raw data points you to something that you hadn't considered previously, well, that's all the better. We had a question, so I want to go ahead and ask this question because it's in context with the taxonomy, and that question was, when adding keywords for the taxonomy as you're building the elements of the classifier, are proximity operators available? So how much flexibility is there with, say, stemming and proximity operators? Do you have, I mean, when you're building the query, you had a full Boolean query up there, but do you have a lot of flexibility with regards to putting in all those different concepts?
Okay, so like you can see on the screen, so if you are adding a phrase, let's say if it contains more than 2 words, then those words will be considered, like while categorization, those words will be taken into consideration in proximity to each other. So user need not add any proximity operator, but system itself will consider that those keywords in proximity to each other for categorization of patterns.
Okay.
Yes. So if the keywords are maternal, fatality, so both the keywords maternal, fatality will be looked at in proximity to each other.
I think
And
part of the question there was that, like, when you said stemming, stems, is that what you're saying also as well? Different
yes.
variations of the word will be covered.
Yeah. So I was coming to that. So for example, we've added this star, like the truncation for complication. So if a star has been added, that means it will also fetch complications, or if it's just complicate stars, it will also fetch complicated. So yeah, that way system will take into consideration different variations of the keywords.
Okay, very good, thank you.
Okay, yeah, so so coming back to the dashboard that we have, so technology breakdown visualization lets you visualize the classification of patterns with respect to the custom taxonomy that you created, and also with respect to the automated concepts which system has suggested. So this option will just give a bird's eye overview of the domain, but for a detailed analysis, we have the option to view breakdown of patterns into these categories using this manual taxonomy option. Next up, we have this problem analysis, which is one differentiating visualization that we have. So we have created a data set of problems by linking all patterns to the problems that is being disclosed in them. So as you can see, top problems chart shows clusters of different problems that are being addressed in this domain. And if you just want to go deeper into that, let's say if you want to look at implant, all the patterns which are disclosing some problems related to implants. You click on that, and then you can see all the patents disclosing the problem. If you just open one of these patents, you can also check or see the exact statement, the relevant text which discloses the problem related to implants. Yeah. And in addition to top problems, users can also track the top companies who are working on these top problem areas. So problem assignee visualization lets you identify top assignees working on these key problem concepts of the domain. Yeah. If you just want to for example, if you're just looking at one problem, you can see who are the top companies in that by double clicking on that cloud form. Then we have this emerging technologies visualization, which is a very interesting dynamic visualization, and it helps to understand the evolution of technologies over the years. So as you move along the timeline, you see which are the top technologies which have been in focus in the last 20 years. And then it also highlights the technologies which have just emerged in the last 5 years. So if we just move on to the year 2021, we see that which are the technology fields which have just emerged during this span of 5 years. And if you hover on any one of these bars, you can see the actual technology field. For example, as we can see, IoT related, like more and more patents are now filing on some IoT related technologies for information processing. So once we have set up the dashboard, we have the data set ready, we have the taxonomy in place, and we already have the dashboard in front of us. You can also set alerts on this dashboard. So very incisive, once you set the alerts, very incisive, and just one-click reports will be sent over the email to you. And then other charts, as you can see, some of the other charts are core publications. Using this, you can identify core patents in this technology space, and also core patents of the top players active in this area. Similarly, you have some visualizations on patent trend analysis. So you can see filing trend of patents with respect to year, with respect to some countries, with respect to top assignees working in this field. And then we've also made this dashboard quite interactive. So users can select any of these data fields and apply filters, and then view the updated charts. So that will definitely help in extracting some hidden insights, and that will, like as per the requirement, you can apply any filter. Let's say if it's on some particular assignee, and you also want to track filing trend for one particular technology, so you can select from the technology category from the taxonomy that you created, and then apply the filter to view the updated chart on the filter data set. Yeah, so that's all related to SDG. Jitin, would you like to add something?
Yeah, thanks, Tuti. I think what is most important is I'd like to flag that we have what we've done is we've created the world's largest data set of problems as well. So we worked with one of the Canadian universities and created kind of went through the entire global patent database and created annotations based upon the problem that was being solved, and that we indexed it, and you can actually search through problems that are being solved. And also in terms of the explainability and giving user the ability to create taxonomies on the fly and on the go, that's an enabling factor that we've enabled within this data set. Of course, there's got to be some level of sophistication in as far as knowledge of the space is concerned. And the more you know the space, the better the output is likely to be. That's one thing that that is required. However, the machine assists you in creating the taxonomies, and we continue to increase those abilities as we move forward. We always look forward to feedback, and as I've already pointed out, the offer of creating a proof of concept and working with companies for a free 3-month period trial is available. And we like to, if anybody in the audience or anybody who's listening later on at the recording stage wants to take that up, we're available for that. Okay, so now we come to, yeah.
Let me just ask a quick question here, because we got a question that came in and it's relevant at this point. The audience question was, what are the technologies behind your categorization system? Is it rule-based or machine learning model? And I, based on what you just said, it seems that it's a combination of both. That the taxonomy based on the concept building that Stuti showed originally at the beginning was likely rules based. I mean, so just run a load of searches, categorize things. But the problem database and some of the automatic categorization, it seems to be more of a machine learning model. Can you speak maybe just a little bit more on, for instance, building the problem database? Is there any additional details you can maybe provide on how you took that huge corpus and managed to tease out all of those different problems?
Sure. So in as far as the learning and the delta from when you're choosing the synonyms or the parallel concepts in the taxonomy is concerned. So when you're building the taxonomy and you're choosing, for example, screen is the same as a monitor, there's a delta that gets created and that continues to learn as one moves forward, right? So anything that you're storing for yourself or for your organization, when you're, for example, here you're saying early detection is in parallel with early intervention, for example, or early warning. That's a delta that is continuing to be stored for your organization within the system, for your organization only or for yourself only as one moves forward. Now that's one, and you rightly said it's a combination of rule-based and non-rule-based systems. We've kept a lot of rule-based systems where we wanted the machine not to self-assume something that you could not stand behind, right? So we've given that rule-based. We've kept a lot of systems rule-based, where we wanted the user to be in charge and the machine not to run away with it. In as far as the problem data set is concerned, that's you correctly pointed out, we've created certain non-rule-based systems there because that was a large data set and we needed to get into it. There was a very sophisticated, it was a 6 to 9 month process that we had to go over. There's also some BERT and there's some BERT and some other GPT models that have been leveraged in that. So that is non-rule based, as you correctly pointed out. Stuti, you like to add anything? Is that you've been Stuti has also been instrumental in working with the team that's developed these some of the systems. If you like to add, please go ahead. Otherwise, I think this covers it.
Yeah, I think you've covered it pretty well. So nothing I would like to add over here.
Okay. So one more question, because it was directly relevant to something you just did, Stuti. There's a question about the organizations, the company names, and what is built into the system with regards to related but not identical names, misspelling, subsidiaries, et cetera. Can you spend just a moment about your assignee, preferred assignee, or your assignee cleanup type features in the system?
So yes, so what we've done is we've done some data enrichments on the base data that we have. And with respect to assignee, it's as we all know that there are different variations for a single name that we have in patents. There could be some spelling errors or some, entity type could be different, INC, Google INC, Google LLC. So we provide different options for that. First level of standardization has been done by us, which pretty much covers, all these different variations. But on top of that, you also give option to the user to further standardize some names. So if user wants to club different assignee names into one, they can select this option of assignee clusters. You'll see just at the top of the dashboard, there's a option of cleanup tools, and under that we have this option to create clusters of assignees. So this is a one-time effort. You can create clusters, assignee clusters, and for that again we have two different options. First is to include all different names that are under which some patents have been filed. So the standardized assignee option lists down all the companies which have at least filed one patent. And then the second option is corporate tree. So even the subsidiaries of a company can be included in the cluster if you want to, if user wants to club them. So using both these options, the standardized assignee and the corporate tree, you can combine different assignee names into one cluster, and that would be saved in the system. So anytime user is doing some kind of analysis on the portfolio of this company, user can use this cluster, and that would include all the different names that have been covered. And all the visualizations and all the analysis would be done with respect to the cluster that user has created.
Fantastic, thank you.
Okay.
Thanks. So now we come to the most exciting part of this, the qubit test, as Tony's created, right? So what Tony and his team have done is, there's 5,000 patents, right, Tony, which relate to the qubit, quantum bit technology, and there's annotation that they have done. The test consists of 5,000 annotated patents in the data set. It's all uploaded on the GitHub, so you can look that up. The links and everything is on the ML4Patent site. There's the machine challenge is to categorize the qubit and non-qubit data. What we did in this test and in this is take this a step forward. We first applied the standard algorithms for not just removing or segregating the qubit patents, but what we did was a step further, Tony. We further categorized the patents into, the qubit patents into subcategories, as you can see on the screen. So we will show you in the next few slides, and also we'll take you on to the platform and show you how it goes. So we've taken about 517 after initial training. We've taken about 517 patents. So what we found was about 283, which we felt which were assigned as being positives. The system was able to find out of the 287, the system was able to find 283. So there was four false positives, and out of the 225, there was 5 false negatives, which is which is what we are in that 97-98% in terms of the accuracy the system was able to get. I would also see that in my 15 years of patent search and analytics career, I've never had the privilege of having two patent searchers or two patent attorneys agree with each other. So as they say, if you've got if you've got 2 patent attorneys in the room, there are 3 different views. So at least with machine learning and some of the explainable AI, you're able to get a consistency and explainability to the proceedings, and you can go from there. So what we can do is, if you go to the next slide, please, what you will see is, what you see is 279 qubit patents, and further it's subcategorized into the subcategories that the human had given it, and then further the top problems are also are also mentioned. So you'll see the relevant set of qubit patents, out of which 279 is the number that was found. It wasn't able to detect some of them, and then we went into the subcategorization of the qubit patents as well. We took the non-qubit, the rest of the patents as presuming to be non-qubit, and did the test accordingly. Next slide. So you're able to also do all the other analysis with the subcategorization and the segregation as you would want to do, and the everything is in the hands of the user, or everything is is given to the user, and then you can do a core invention study, you can do core publication study, you can set alerts, you can also further get in new data sets, and take it from there. So Stuti will now show you how we ran the qubit set on the system, and then we'll take it from there.
Yeah.
This is an amazing. This is an amazing study. In one of the things that was being talked about throughout my time at Oxford as well was, how do you define and how do you standardize AI, right? If 9 times out of 10 there's an accident, the AI is not responsible. The 10th time that the accident actually happens, how do you define what is a perfect AI? So Tony, this having this gold standard data set is a great step. Go ahead, Stuti, please.
So yeah, so we took around 500 patents from the data set which was on qubit generation for quantum computing, and then we created taxonomies. Created a taxonomy stating different categories under which these patents can fall into. So if you can just go to the taxonomy, you'll see that what Jitin earlier mentioned is that the objective was not just to categorize patents as, the ones related to qubit generation and the ones which are not, but it was also to go a step deeper and see which are the subcategories under which the qubit related patents are falling into. So as you can see, the main category is qubit, and then under that we have some subcategories like quantum dots, and then further under quantum dot we have silicon dots, others being trapped iron, topological qubits, diamond vacancies, so on and so forth. So once this taxonomy was created, and again for creating this taxonomy we took assistance from some of the concepts which systems suggested, and also included some different variations from the corpus. And then once we submit it for categorization, we see and analyze how these patterns are falling under the categories. Yeah, so as we already mentioned, so around 287 patents are falling under these all, it's a combination of all these categories, which are, as we have already shown that these are related to qubit. So around 287 patents have been categorized under these categories on qubit, and then further we can analyze them through our dashboards, which for example technology intelligence dashboard, and which we've already shown in the previous slides, that different visualizations that we can have over here, like portfolio summary, just to get the overall breakdown of the portfolio. Then pattern trend analysis, as we have already discussed in the SDG dashboard. And then we can see the top problems which are being addressed in this technology space. So see, these are some of the problem clusters related to the patterns that we have on qubit generation. And then, as we've already seen, emerging technologies, which shows the evolution of technologies, in the last 20 years, and then also highlights the ones which have just emerged and are being looked at in the recent years. So that's all from our side with respect to the presentation. We are open to questions now. And to all the attendees, we also have an offer which includes 3 months trial access of the platform, and also along with that comes a proof of concept case study. So if you have any questions, we are happy to answer them.
I got a quick question. The qubit data set was about 5,000, right? You cleaned it up to about 500. If you apply the taxonomy to the 5,000, what kind of noise do you get? How clean would that data be without the first cleanup?
So we've taken a subset of the 5,000 patents. And even if we apply the taxonomy on the complete data set, because out of those 5,000 patents, some of the patents were positive as in they were directly related to qubit generation, and some of them were negative. So all the patents which are actually positive related to qubit generation will definitely be categorized in all these categories. And as we have seen, the accuracy of the explainable AI-based categorization on the 500 patents, so we see similar would be the accuracy for the complete data set.
Okay.
So it's also worth noting that 5,000 is a bit of a misnomer. There are 5,000 which include all of the family members.
Yeah.
So it's really only 1,500 when you reduce by any reasonable family association. So when the set was created, it was sent as a family, 500 positives, 1,000 negatives. And the people who ended up putting it up on GitHub thought, just for the sake of completeness, let's expand the families into all of the individual documents. And that's what they put up there. So that regardless of which family member you might have been working with in your system, it was still going to be categorized as being part of the positive families or part of the negative families. And so, yeah, so it's important to keep in mind that that particular collection is family expanded. So it's a lot more individual documents as opposed to the individual families.
When the system was going through, Tony, you're completely right. When the system was going through some of those references, there was an anomaly that it detected as well, that one family member was of the same family was detected as being part of the qubit, and the other one was detected as not being part of the qubit. So it also detected that anomaly, and that was part of the anomaly detection that the system had.
Yeah, that's fascinating. It doesn't surprise me though, because of course of all the different types of family designations, a DWPI family, for instance, is going to be technology specific. And so if one member of the family was a qubit generation and another one was software for the use of qubit generation, with an expanded family, those are going to end up in two different, one's going to be negative and one's going to be positive, even though they would be, say, part of the same DWPI family and the same INPDOC family, but not necessarily, excuse me, they'd be in two different DWPI families, but the same INPDOC family. And so I can see how that might occur. Let me ask you a question. We've got one here, and could you go back to the qubit set and let's take a look at, say, the companies or the assignees that are associated with topological?
Sure. Pranav, can you go back to that?
Can you repeat? It broke in between.
Yeah, just go back to the qubit patents. Yeah. So Tony, can you repeat the question, please?
Yeah. Yeah. So okay. So great. So they here under the assignees, you've got a subsection for topological qubits, and so I was just curious which assignees were showing up specifically under topological.
Okay.
Yeah. See, so very good. That's what you'd expect to see. Northrop Grumman is one of these companies that I think doesn't get a lot of attention in the quantum field, but actually has quite a bit of really good IP. This is a play that Microsoft, when you look at the big companies in quantum computing, you basically got Google, IBM, D-Wave, and Microsoft, and all of them have quite a number of patents in superconducting loops. Superconducting loop is most of the computers that are out there now are using superconducting loops. Ion trap and topological are sort of next generation qubit generation technologies that potentially provide some advantages. And so it's always really interesting to look at some of these emerging areas in which companies seem to be getting a leg up on if they can work out some additional details and work through scalability of some of these alternative qubit generation methods, that those companies would be really well positioned to be able to take advantage of those advances. So thank you for showing me that. That's exactly what I was hoping to see. And then the question that came in through the panel was, as far as your corporate tree is concerned, where do you get the names for your company subsidiaries? So what sources are you using to create your corporate trees?
So we're getting the first set from FactSet. And Stuti, anything else you want to add?
Yeah, so we're getting the corporate tree data from FactSet. And with respect to the assignee names that we have from patents data, we are further standardizing them into 4 fields like current assignee, original assignee, and then current assignee standardized and original assignee standardized. But the corporate tree data is being sourced from FactSet.
Okay. Well, very good.
This is where I like to also come on to a philosophical point here. Is the way the IP department is positioned currently is like a downstream function. But when with a very sophisticated corpus that you could have, there is the opportunity for recycling all the knowledge back into business and corporate by leveraging all the knowledge that you're kind of adding into the corpus and leveraging it for others in marketing, in research, in other fields. Also, for example, you pointed out one area of quantum computing. Now, there would be a specific department within the company that might be interested in what's happening in that area of technology. So the role of the IP department in a real-time scenario would be, rather than sending one report in a year, would be send real-time reports every week, every 2 weeks, and send them, systematic alerts on what's happening. So the IP department is able to percolate much more into other aspects of business and not just continue to do the functions related to drafting patents, litigating, enforcing certain licenses, but also be a repository of knowledge and and data as one moves forward. That's
Yeah, I was
what
going to
AI.
ask about that. I noticed that there was a button to update, and so it seems as if the say a weekly or a monthly identification of new documents and automatic classification of those is something that's built right into the system, and alerts can be created that way, and everybody who's has access to the system can recognize and see when there's new data to look at.
There's a button related to alerts, and you can set that up, and then you can also send email, like reports and email, which is almost looks like somebody human has developed that report. So a report goes to the person who's set that alert, and then at the back end it kind of runs. For example, if you're just setting qubit superconducting loop alert, and then you're setting it up for one of your colleagues in research and development, just enter the email address and it goes to that person. The update is actually for it to update once you've changed the category. It just takes some time and updates the category there. So that's what the update is. The alert is that function that does the same.
All right, well, fantastic. We've gone through all the questions. We are almost at the top of the hour. More than 90% of the people who started with us stuck around through the first 50 minutes. So that's fantastic engagement. For those of you who are still here, remember, please, short survey at the end, including the offer for 3 months. The quickest way to get in touch with XLSCOUT and get yourself set up that way is to go ahead and just say yes. The report will have your email address and somebody will be in touch. But I want to thank all of you for joining me today. Fantastic session, great level of explanation and detail, lots of detail about exactly how the system works and what people can expect. And so once again, thank you to everybody who attended. Thank you to everybody who presented. And that's going to be it for episode 7. So have a great remainder of your day, and just make sure you fill out the survey and let us know if you have any other questions. Thanks so much.
Thank you. Thank you.
Thank you.